Hello, welcome back. So now that we have seen in the previous session, we have applied a few of the text processing or text cleaning steps. We have applied basic and also advanced text cleaning processes, and we were arrived with the cleanest form of text with uh, after elimination of white spaces, extra special characters, HTML tags, if any, digits, numbers, etc. So now that we have only purest form of letters or characters or words without any punctuations or any other forms of textual orientations. So now it's time to have another perspective about our text. Okay. So given a sentence, we would be generally curious about what would be the in our data set, what would be the longest sentence available with us. So our how many words are present in a longest review that is written by a customer. So why did he write that? So why exactly he has taken time to write that, and what exactly he has written? All those things. So we are trying to determine the numeristic features, or in other ways, the metrics of identifying the number of words, characters, and uh, that particular aspect of a text in this session. So what is the advantage of it? So first of all, we will be getting to know what are the outliers in our data set, right? So what exactly our data contains and what exactly the outliers present in our data set. So what exactly outer layer defines? Outliers are nothing but irregulars or irregularities in the data set. So out of 10, maybe 9 will be very good and 1 will be out of range, and that cannot be utilized or cannot be considered for the further analysis as well. So to analyze those aspects, so we are going to jump into this session to know about the characteristic features of a sentences of the reviews basically. So first of all, what we'll do, we'll get a word count. So we have different reviews, and each review is a sentence already. So what we are trying to do in this step is we are picking up the word count for each sentences. So let's do that. So given that our data frame is a review, uh, I have created another data frame with another row called review word count, which is equals to data frame of review dot apply lambda function. So what I am trying to do, I am taking each and every word, and I am associating the count associated with it. So I am basically counting each and every word in a given sentence. So how I am going to do? See, in the above sentence, what you can see, an example sentence, I can just count it in this way, right? So awesome, love, album, good, hip, hop, side, correct. So 1, 2, 3, 4 in this way. So I'm basically doing it, and or I am already considering each and every word as an individual uh, term based on the spaces, right? So that's what I am going to do. I am going to apply the lambda function. What I am going to do, a length of string of x dot split based on the spaces. So the splitting based on the spaces yields each and every word separately. So now I am going to count the length of it. So that is the length of each and every, like after splitting it into spaces, we will be definitely ending up with a list of all the words. So I am taking that length basically. So length of list will yield the total number of words in the given sentence. So that's what I am trying to do over here. So lambda x is to length of string of split based on spaces. So this will internally return me a list of all the terms. So I am taking the length. So once I get the length, I am going to populate in this particular list. So let's have a look, and you will get to know how exactly it will look. So for the given sentence, the very first example, it has 21 words. Then there is another sentence which has 17 words. Similarly, another sentence with 3 words. So this is how I got the word count of each and every sentence in the data frame. So we can't actually sit and iterate on each and every sentence and look at the count of each and every word. We have a another tool, better visualization tools, that is a Seaborn SNS, which we have imported at the very first or the very beginning of the session. So we'll try to plot a graph. So the graph will be basically sentence versus word count. So by this, what we will be getting? We will be getting a accumulation or outliers, and what exactly the average count of the words present in the given sentence. So we'll do that by this way. So since I am already available with the word count data frame or a word count row, so I am taking that and I am going to plot a histogram. So what does histogram do? Histogram will basically plot a term versus count basically, and it actually gives the distribution along the data frame. So since I have taken an entire data frame with review word count as a column, so on this it will apply histogram. So it will basically distribute the count of each and distribute the count of words in each and every sentence. So I have grouped them in bins. We can do it anyway. So I have grouped them into bin of 180 by 5, and I have taken a color of dark blue. These are the other aspects like edge color or the line width what we can define. So these are all the other parameters which we can define when we try to plot a dist plot. So what does this dist plot in term refers? Distributed plotting, right? That is a density plot of histogram of all the words. Okay, so by running that, we will be getting this particular curve. So this is a histogram. Histogram consists of a x and y axis. Here the x axis refers to the word count, and here on the y axis it refers to the occurrence or the number of times uh, this count is present in the data set. So I could clearly see that the maximum number of times the sentence will be available with 15 to 20 words. So that is what it is showing. So highest number of count of sentences or highest number of sentences have word count as 20, and you could see the outliers lying around 600 as well. So there are sentences in our database or a data frame where the word count is around 600. So these kind of sentences we can ignore or we can consider it as a outlier. Now that we have seen the word count, now it's time to get into furthermore deeper step to get a count of character. So what does character count refers? Word count is a one single term. What does character count refers? The count of each and every letter in a sentence. So definitely a character count will be in a larger number when compared to word count, right? So we are going to count each and every character, and we will try to plot that in the similar manner. So that's what we are going to do in the next step. So similarly, instead of word count, I am going to take a review character count, and the functions which I am going to apply remains the same, except I am just taking a length of each and every character. So what I am going to do, I am going to take each and every character length. So that's why it will also include the spaces as well, right? So what does this function will do? Review.str.length, what it will do, it will try to count each and every letter in a given sentence, including space as well. So based on that, when we look at the data frame, what does it shows? The very first sentence which had 21 words, now we can see that it has 116 characters. Similarly, the other rows as well. So what we will get when we plot the similar graph as a word count for the character count. So this is how we are going to get a distribution plot. The similar plot which I am going which I have used for the word count. The similar plot I am going to apply for the character count as well. So you could just see the character count of around 100 basically. So 100 would be the character count that appears most of the times in the entire data frame. That is, highest or the most repeated number of character count in our data set is 100, and the word count is around 15 to 20. Right, you agree that, right? Because if you could see, the 21 is the word count here, and for that respectively the character count is around 116. So what we can say, this will be a generalized form of sentence, or this will be a general sentence length what we could see in the entire data frame. How are we going to say this? That is based on this particular plot which we can see it over here. Then we will try to analyze another form of metrics, that is word length, average word length. So we have seen the word count, character count. Now what we will see, we will try to analyze what will be the word length, average word length in our entire data set. So average word length is in this way. So I am going to define a function called average word, and I am going to pass a sentence. So that is what I am going to do. So I am going to pass this entire sentence to this function. So I am going to split that. So if you won't specify what it is inside this bracket, it will be default. By default, it will be splitting the sentence based on the spaces. So then what I am going to do, sum of length of word. Instead of saying this way, I could just first start with the for loop. So what I am trying to do, for each and every word in the words, so sentence dot split will return a list of words, right? So it will be a list of words. So I am going to take that each and every word and length, and I am going to sum that divided by length of words. So that is how you will take the average, right? So in a given, for example, you have two values, say 5 and 6. You want to take an average. What we will try to do? We will try to add 5 and 6 and divide it by 2. So that is for two different words, right? So the two different values. Now it's for all the words. So average word length for all the data set. So for that, what I'm going to do, that is I'm going to take a sum of each and every length of words, or length of words present in a given sentence, divided by overall length of each and every words. That's what I am going to do in this step. So when I apply this on this particular data frame, the average length of each and every sentence will be 4.8, 5.7, 4.6 in this way. So we have a average word length of 4.8. So you could see in a sentence we have a word length of around 4.8 for a given sentence. This is what this function yielded me. So now if I plot this in a similar fashion, that is a distributed histogram, what I am going to see is this curve. So in our entire data frame, or in our entire data set, on an average, the word length for a given sentence would be around 5 to 6, or 5.1, 5.2. Okay, around 5 what we can assume. So on an average for a given sentence, the average word length would be 5. That's what this plot yielded me. Now it's time to analyze another aspect, that is common words are occurring in the entire data frame. Why we need this? We'll get a better understanding what our data sets actually speak about by taking the common words, or a common top common words. So this will yield me, or it will give a insight about what exactly the entire data set is actually speaking about. So for that, what I am going to do, I am going to take this frequency that we have already imported above. So I'm going to take a frequency distribution for the terms. This is a function which I am going to define first of all. So frequency of words equals to x comma terms equals to 30. So I am going to take the maximum term count as 30, because I'm going to take a top 30 common words, right? So all words equals to space dot join text for text in X. So what is it doing? So it is trying to take each and every text in the in a particular sentence, and it is going to join into a one particular word or a one particular sentence. So it's keep on appending by sentence. It will be keep on appending one word to another, and it is creating a one large set of words. So that is why I have taken the variable as all words. So all words equals to all words dot split. So it will again yield me a list of all the words in the entire data frame, right? It is not about one particular sentence. It is about entire data frame what I am going to do in this particular step. So when I get a list all words equals to all words dot split, it will be a list of all the words present in a data set. Why I'm going to create this list of all the words? That is to find the frequency distribution, right? So when I get the list of all the words, then I could see the frequency of those words occurring in a particular list, right? So it is a very easy way to do this when I get a list of all the words in one particular place. So that's what I'm going to do. I have defined this frequency distribution, and I'm going to pass all the words. That is what which I have got a list of all the words. Then I'm going to take a pause over here. What does this say? PD data frame word is to list of frequency distribution dot keys, count is to list of frequency distribution of values. So this particular function, uh, frequency distribution, or imported, the function which I have imported above, what this will do, it will basically give me a key value pair. It will take a word in a given list. For example, say I have taken this particular sentence, the second sentence, which is very simple. So it will take each and every word. It will try to count the occurrence of this word throughout the sentence. So it will take this good. It will try to see whether this good has occurred any other time within the sentence. If so, it increases the counter of that word. So what it will basically do, it will take a word good is to the count as a value, key value pair basically. So good is to 2, review is to 1. So this is how it is going to create a pair of word versus count. So that is what this function will do, the frequency distribution will do. So when I am going to pass all the words for this frequency distribution, then I am going to get a entire large set of list which consists of pair of key and a value. The key is a word and the value is a count of that word in the entire data frame. So that's why I'm going to create that, and I am going to utilize it into a different way. So I'm going to assign the key as a word and count as a value. So that's what I'm going to fetch it here. So once that is done, I'm going to plot this using a plot. That is not a Seaborn plot, it's a normal plot using matplotlib. So that's what I am going to do. I'm going to take the df.n largest, that is column equals to count and n terms. Then I'm going to plot a figure of size 20 is to 10. Then I'm going to plot a bar plot. So I'm going to pass this entire data, that is data frame, that is the words of basically the count of each and every word, and I'm going to assign it to x and y as a word. So basically I'm going to create a plot with y-axis as a word and respective count associated with it on the x column. So I'm going to set that labels as well. So I'm going to name the y label as word. You can do this optionally or you can ignore this. So when I plot this, you could just see you have a, as I labeled the y label as word, so you will be seeing it over here. And since I have taken x values or the x uh, axis as a count, so it will give me the overall count count of each and every word in the entire data frame. That is, it is at the distance of 5,000, 10,000, 15,000 at a scale of 5,000 increment. Then y would be the word. So as you could see, in the entire data set, great is the highest occurred word, or the occurrence of the word great is around 35,000 times. What does this mean? This is basically a review which is speaking, or where the customers are actually speaking in a positive way. And what are they speaking about? A movie or a use or a product, etc. So by these few words, we could just analyze that, okay, this is a particular data set, or this particular review data set speaks positively about something. So that's why this word great has occurred so many times. So many times, that is, it is almost around 35,000 times that particular word is appearing. So now that we have seen entire entire picture of occurrence of each and every word in the data set, and I have also plotted the bar plot of each and every word versus the count, we have got a gist about the highest or the most occurred word. So in the next session, what we'll do, we'll try to do the opposite of this. Which word appears the least times? In other words, we will try to find out the rarest occurring words in our data frame.